Okay, today we start the numerical of the chapter volumetric analysis, which was important for your NEB examination. 0.4 gram of a divalent metal was dissolved in 50 cc of 0.64 normal HCl, and the solution was diluted to 100 cc. Then 25 cc of this solution required 27.3 cc of 0.11 normal NaOH for neutralization. Find atomic mass of the metal. For such type of the question, we need to start with the clue, that is for neutralization. For neutralization, (27.3 cc of 0.11 normal NaOH). This is equals to 25 cc of solution. This is equal for the neutralization, but we need to find out the 100 cc of this solution. 1 cc of solution equals to 27.3 cc upon 25 of 0.11 normal NaOH. 100 cc of solution equals to 27.3 upon 25 into 100 of 0.11 normal NaOH. That is equals to 109.2 cc of 0.11 normal NaOH. In this type of the question, we have given the case of the metal. This metal was dissolved in the acidic solution, and this acidic solution is diluted to 100 cc, and again some part of this is reacted with the base. So here the acid, same acid was mixed with the divalent metal and then with the NaOH solution. So number of gram equivalent of acid equals to number of gram equivalent of base plus number of gram equivalent of metal. So here we have given, we know the formula that the number of gram equivalent of acid, that is N1 B1 upon 1000 equals to number of gram equivalent of base N2 B2 upon 1000 plus number of gram equivalent of metal. Here we have not given the normality, so we use the different formula, that is weight of a divalent metal upon equivalent weight, or normality of acid is given 0.64, volume of the acid is 50 cc, 50 upon 1000 equals to base 0.11 into its volume 109.2 upon 1000 plus weight of a divalent metal, that is 0.4 gram upon equivalent weight. The formula of equivalent weight is atomic weight upon valence, or 0.6.032 equals to 0.11 into 109.2 divided by 1000, we get 0.012 plus this valency is multiplied in upper section 0.4 into 2 upon atomic weight. So we need to gather the like terms 0.032 and 0.01 or 0.032 minus 0.012 equals to 0.8 upon atomic weight or 0.032 minus 0.012 that equals to 0.02 equals to 0.8 upon atomic weight. Now we need to crisscross here or atomic weight equals to 0.8 upon 0.0. Therefore, atomic weight of metal equals to that is 40 AME. This is the required solution we need to come up with such type of the question. Here we need to start with the clue that is for neutralization. This is the some clue where we need to start off with. As the solution is diluted to 100, so we need to calculate the 100 cc of the dilute solution. Then we can come with the volume of the base, which was used in the number of the gram equivalent of the base. So number of gram equivalent of acid N1 V1 upon 1000, gram equivalent of base N2 V2 upon 1000, number of gram equivalent of metal. If the normality is not given, we have the another formula also, that is weight of a divalent metal upon equivalent weight. And when we calculate all these steps, then we get the atomic weight of metal is equal to 40 AME. Okay, this is the another important question from the chapter Volumetric Analysis. Here, the question begins. If 20 ml of 0.5 normal NaOH is mixed with 30 ml of 0.3 normal HCl, is the resulting solution acidic or basic? We need to calculate the normality with respect to the acidic or basic solution. For such type of the question, we have the easy trick, that is N1 V1 minus N2 V2 equals to NEB. This means for such type of the question, you need to have the such formula, then it is very easy to get the answer of such type of question. In all prospect or in all aspect, you need to consider the acid is the N1V1 and base is the N2V2 and the resultant is NEB. Or here we have the normality of acid is 0.3. Volume of that acid is 30 ml minus. Now normality of base is 0.5 and its volume is 20. Total normality is equal to, which we need to find out, and total volume is 30 plus 20 is 50. 0.3 into 30, that equals to 9 minus 0.5 into 20, that is 10, equals to ND into 50. Therefore, resultant normality equals to 9 minus 10, that is minus 1. That means the resulting solution is basic. But the resultant normality is 50 upon 1 upon 50. 1 upon 50, that equals to 0.02 norm. So this is the solution of such type of the question. We have calculated the resultant normality and also find out the resulting solution is basic, because we have get here the negative. If we get the answer in positive, then the resulting solution is acidic in nature. This is also the most important question for the NEB examination. 1 gram of a divalent metal was dissolved in 25 ml of 2 normal S2SO4. This EF is the normality factor which needs to be multiplied in case of writing the normality, that equals to 1.01. The excess acid required 15.1 ml of 1 normal NaOH, whose normality factor is also given, that is 0.8, for complete neutralization. Find the atomic weight of the metal. Now for such type of the question, the same acid reacted with the metal and remaining amount of the acid is reacted with the base, that is NaOH. If we have the OH ion at last, that is called the base, and S2SO4 is the acid. So the same acid is equal to the number of gram equivalent of base and number of gram equivalent of metal. So number of gram equivalent of acid equals to number of gram equivalent of base plus number of gram equivalent of metal. So we have the formula. The number of gram equivalent of acid is N1B1 upon 1000. Number of gram equivalent of base N2B2 upon 1000 plus number of gram equivalent of a metal, that is weight of metal upon equivalent of normality of acid. We have given 2 normal, but we have also given the normality factor. So we need to multiply this normality with the normality factor in the value of N1. 2 into 1.01, and we have given volume, that is 25 upon 1000 equals to N2, that is the normality of base. Here we have also given the normality factor. So one needs to multiply with 0.8 and volume is given 15.1 upon 1000 plus we have given the weight of the metal, that is 1 gram. Then the formula of equivalent weight is atomic weight upon valence. So we need to calculate this 50.5 divided by 1000. From here we get 0.05 equals to 1 into 0.8 into 15.1 divided by 1000, that is 0.012 plus. Now here we have 1, this valency is multiplied with this value of 1. Here we have given the divalent metal, so the valency is 2. 1 into 2 upon atomic weight. So make the like terms in both the sections. Here 0.05 minus 0.012 equals to 2 upon atomic weight. So now we need to do a crisscross here. 0.05 minus 0.012, that equals to 0.038. 0.038 into atomic weight equals to 2, or atomic weight equals to 2 upon 0.038. Therefore, atomic weight of metal equals to 2 divided by 0.03, that is 52.63 M. For this question, please don't confuse with the value given, that is F equals to 0.8 for NaOH and F equals to 1.01 for acid, that is S2SO4. For such type of the question, we need to multiply this normality factor value with the normality value. Here we are multiplying that. So all of these for this question. We need to also know one equation for NEB, which was asked in the year 2018. Your chemistry teacher added 4 grams of sodium hydroxide. This means it is a base, sodium hydroxide, in a bottle containing 20 cc of 2 normal S2SO4. We know this is acid, and he diluted it up to 1 liter by the addition of water or by adding water. Then you have given a blue and a red litmus paper. This means if the resulting solution is acidic, then we need to use a blue litmus paper, and if the resulting solution is basic, then we need to use the red litmus paper, because in acidic solution blue litmus paper is changes into the red litmus paper, and in the basic solution the red litmus paper is converted into the blue litmus paper. So we have the question here, which litmus paper would you use to test the solution, and we need to calculate the normality of dilute solution. So we have to write the reaction first. NaOH plus S2SO4, it gives Na2SO4 plus water. Now we need to balance this equation. Here we have the 2 number of sodium, so we need to add 2 here, and for balancing the hydrogen we need to add 2 here. So from here we came to know that 2 mole of NaOH is reacted with 1 mole of S2SO4. That means 98 gram of S2SO4 is neutralized by 2 mole of NaOH. That means 1 mole of NaOH equals to 40 gram. So 2 mole of NaOH is 80 gram. 80 gram of NaOH. Now here we have given the 4 gram of the sodium hydroxide, and also there is a clue that 20 cc of 2 normal S2SO4. From there we need to calculate. We know that normality equals to weight of solute in gram, upon equivalent weight into 1 upon volume of solution in ml into 1000. So we have given here normality to weight of solute in gram, we need to calculate. So let us consider X. Equivalent weight of S2SO4. In case of S2SO4, when we undergo the ionization, it gives 2S plus ion. So if we divide the molecular weight by 2, that means the basicity of acid, that is the equivalent weight. So its equivalent weight is 49 into 1 upon volume of solution in ml is 20 ml of C6 into 1000. Or now we can do crisscross here. 49 into 20 equals to X into 1000. Therefore, X equals to 2 into 49 into 20, which is divided by 1000. that equals to that is 1.96 gram. Here 1.96 gram of S2SO4 equals to 80 upon 98 into 1.96 gram of NEB. This is 80 divided by 98 into 1.96, that is 1.6 gram of NEB. But we have given the 4 gram of NEB. So here the residue is NEB. Therefore, resulting amount of NEB equals to 4 gram minus 1.6 gram, that equals to 2.4 gram. Also, if we found that the resulting solution is basic, because there is the resultant amount of the NEB. So, is the resulting solution is basic, we use red litmus paper. Now again we need to calculate the resultant normality of the dilute solution. For this we know the formula that gram per liter equals to normality into equivalent weight, or we obtain the amount, that is 2.4. The solution was diluted to 1 liter, that means 1 normality we need to find out it, and the equivalent weight of NEB. Here the equivalent weight and molecular weight of NEB is same, because there is only one OS ion. This is equal to 40. Therefore, normality is equal to 2.4 divided by 40, that is 0.06 norm. This is the solution of this question. If you like my video, you can subscribe it or gain a knowledge from it. If you have any doubt on the other prospect or any other question, then you can write it in comment, and I can come with the part 2 of the volumetric analysis if it is necessary. Okay.